my name is Jenna Mobley. I'm a middle school science teacher in Washington State, and I'm excited to walk you through this first lesson of your new science unit. This lesson takes place over the course of a couple days, and it's possible you only missed one of those days. So if you need to, skip ahead. And one of the advantages of a video is if things go too fast or you need to, go ahead and go back and rewatch anything that you need. I will ask you throughout the video to pause as needed in order to write down some notes. Go ahead and just play as soon as you're ready to move on to the next part of the lesson. Before we get started, you're going to want to make sure that you have a couple of materials. You're going to want a science notebook. If you don't have a science notebook, some scratch paper or printer paper will work. You're also going to want to make sure that you have a writing utensil to add to your science notebook. There are 2 handouts that you will use in this lesson, and I have them available digitally. You can use this link in order to access them, and I will post that again once we need it. And if you already have them printed, fantastic, that will work just as well. All right, throughout this unit, we are going to explore an interesting phenomena. So I recently thought about bath bombs more through a science lens, so as a scientist would. And I was curious, are you familiar with bath bombs? Have you heard of bath bombs before? And what is your experience with them? And then, if I had a big bowl of water, what would happen if I placed this store-bought bath bomb in that big bowl of water? If you were in the classroom, you would talk with a table partner about this, but since we are not, I'm just going to ask that you make some notes to yourself. Go ahead and pause until you have those done, and once you're ready, click play and we'll watch the next part. So students in another class said that bath bombs fizz in water. They predict that when this bath bomb is placed in a bowl of water, it will fizz. They know that bath bombs change the bath water color, that they smell really good, that they have received bath bombs as gifts, and they also they like to give them as gifts. They come in different scents, they're colorful, they smell nice, they dissolve. Some people have them on their Amazon wish list. Some people have zero experience with bath bombs, and all of those are okay. Maybe they match what you have, maybe they add something new. So we're actually gonna see a couple videos of a store-bought bath bomb being placed in a bowl of water. So I would like for you to set up a Notice and Wonder T-chart, just like the one that's on your screen. So please title the page Store-Bought Bath Bomb, and then draw a T-chart just as shown, and let's label the left Notice and the right column Wonder. We're going to watch these 2 videos, but if you have a bath bomb at home and permission from your adult to do this, go ahead and do that instead. But if you don't, you'll get all the same experience by watching the video. I like to tell my students to aim for at least 3 noticings and at least 2 wonderings. And a noticing is anything that you see, you hear. This video does have sound. You won't be able to feel the bath bomb because unless you're doing it at home. But the second video does include the person making the video giving some observations about what it feels like. And we don't taste, or you won't be able to smell in this video. Wonderings are any questions about like what's going on, how it's working, those kinds of things. So let's go ahead and watch this first video. Now that you have watched the first video, go ahead and write down some noticings and wonderings, and get ready to watch the second video.
This foam is kind of slimy, and so is the water underneath. It's slippery feeling.
All right, go ahead and pause here for a moment, update your Notice and Wonder page with observations and questions that you have. So now that we've had a chance to look at a store-bought bath bomb, we're going to look at some homemade bath bombs. And the reason is we're going to look at bath bombs for most of this unit. And if you have purchased bath bombs before, you know they're kind of expensive. So I found some homemade recipes that I wanted to share with you, and we can kind of think about like, how are they the same? How are they different? I think they'll still help us figure out like what is going on with bath bombs? How are they working the way that they are? So title the next page in your notebook or your scratch paper, Homemade Bath Bomb Observations. If we were in class, you would be given 3 different homemade bath bomb samples. I made 4 different recipes and some tools in order to make some observations about those bath bombs. So you'd be given paper plates, toothpicks, a pipette. Those are the little plastic eyedroppers to add water, clear plastic cups, water from the sink, and paper towels for cleaning up. I'm going to show you a video of me kind of poking at the bath bombs with the toothpick and then using the pipette to add water. And I'm going to ask that you add your observations to the page that you just titled Homemade Bath Bomb Observations. Because there's 3 different recipes, I'm going to recommend that you practice a little bit of notebook organization and actually label 3 different sections with the bath bomb recipe letter so that you can keep those, tell those apart when you go back to look at your observations later. It also might be helpful to think about like what kinds of observations would we want to try to collect about the homemade bath bombs to help us figure out what happens when the bath bombs are added to water. So I'll play this video next for you. Go ahead and make your observations about each bath bomb recipe. All right, pause here and add some homemade bath bomb observations to that page if you haven't already, and click play whenever you're ready. If you were back in the classroom with your classmates, we would have a whole class discussion about how these homemade bath bombs compared to the store-bought one that we watched being dropped in the big bowl of water. Did they do the same thing? What was similar? What was different? I would like for you to just add a couple notes below your homemade bath bomb observations about what happened, how they compared, what was similar, what was different, and click play whenever you're ready to move on. So these were some homemade bath bomb observations from a student. They said recipe A was yellow, it smelled like lemon, it dissolved well, and it had big bubbles. Recipe B was really fizzy, but it did not dissolve as quickly, and there was no lemon smell. And recipe C smells like coconut with a question mark, like kind of coconutty, but maybe not sure. It was soft feeling, it was a perfect cube, and it didn't dissolve as well. It looked kind of oily on the top. So your observations will likely be different because this student included observations about the smell, which you were not able to tell through the video. Does this add anything to the differences between the store-bought bath bomb that you looked at, maybe to your homemade bath bomb observations? Did they do the same thing? Does this help us at all with like what is going on when we put a bath bomb in water? So to help us continue to figure out like what is going on with these bath bombs, we're going to develop an initial model. This is just your thinking at this point in time, so I'm not asking for perfection here. But I would like for you to use pictures, symbols, and words to represent what happened to the solid bath bomb and where gas bubbles appeared in the system. So there's 3 points in time. The first is right before adding the bath bomb to water. What happened? Where were the water and the bath bomb? A couple seconds after adding the bath bomb to water. What happened? What was in the system then? And a few minutes later, so after it had a little bit of time to fizz. What happened then? If you don't have access to a printer or don't have this handout, please just draw the little cup diagrams and you can still represent your thinking that way. Please pause this video for as long as you need to add your thinking, and then when you're ready, click play, and we'll add a little more detail to it. All right, so now that you have your diagram, I would like for you to label 4 different spots on this diagram. So with the letter A, you're going to label a spot in the bath bomb before you add water to it. Label a spot in the water right before adding the bath bomb to it with letter B. Letter C is going to be a spot in the liquid remaining in the cup a few minutes after adding the bath bomb to the water. And letter D is going to be a spot inside of the gas bubble a couple seconds after adding the bath bomb to the water. So letters A and B should really be in this first cup here. Letter C is a few minutes after, so that's going to be somewhere in the last cup here. And letter D is going to be just a couple seconds, so that's somewhere in the middle cup here. So go ahead and label those spots. Then I'm going to show you another student's representation, and this is what they have labeled. So the solid bath bomb has A, the liquid before we add the bath bomb is B, the gas bubble is represented with D, and the liquid after is represented with C. So yours might look similar and might look different. Both are perfectly valid. So the next thing that we're going to do is take that diagram that we sketched and work on a model that gets at like what's happening on a smaller scale. These blue bubbles here we call zoom-ins, and they're trying to like beyond what we can see with our eye, what is going on. So the letters on here correspond to the letters that you just put on your diagram. So A is the tiny sample of the solid bath bomb, B is the tiny sample of the water, D is a tiny sample of the gas in a bubble, and C is a tiny sample of the liquid left over after a couple minutes. If you don't have this handout already, there's the same link before, it's just the second page of the document, will take you to this. You can work on it digitally, you can print it. If you don't have access to a printer, draw 5 circles and do your best to represent your thinking at this point in time about what is going on a scale we can't see yet. Pause here for as long as you need, and then when you're ready, click play, and I'll show you an example of one of my students' models and give you the opportunity to compare the two models. All right, now that you have finished up your model, I'm going to show you one of my students' models, and I'm going to ask that you do a little bit of comparison. So anywhere where there's parts of your model that match this one, I'm going to ask you to put a check mark. And anywhere where there's either difference or you're just less certain, go ahead and put a question mark. And when you're comparing things, I'm going to encourage you to think about the process of what's going on with the bath bomb, and less like they drew nicer circles than I did, or they used blue to represent this and I used orange, or I used dots. So things that were similar in like how you understood what was going on with the bath bomb, and less how you illustrated or your art. So go ahead and pause here, take as long as you need to do a little bit of comparison, add check marks anywhere there's similar pieces, similar explanations, and question marks anywhere there's difference or just a little bit less certainty. And go ahead and play whenever you're ready to move on. So in the classroom, we would make a full class consensus model. So we would take as many of the ideas that we could, that we all agreed on, and we put those on one big model. And anywhere where we have questions or maybe just not clear understanding, we would put question marks on. So since you're not able to make the class consensus model with us, I'm going to ask that you go look at your class's consensus model when you return. In the meantime, I'm going to show you an example class consensus model. Just be thinking about like what pieces of your model are showing up in the class consensus model that I'm showing you. Is there anything that's different? So this is a class's initial consensus model of what was happening at a scale we couldn't see in the bath bomb. So they have a tiny sample of the bath bomb represented with green circles, pretty tightly packed together. And then a tiny sample of the water with some blue circles down at the bottom left. Right after adding the bath bomb to water, students think that it's maybe breaking apart, melting, possibly boiling, reacting, releasing, and interactions. Those all seem to have question marks, so it sounds like there's some uncertainty there with this class. Then as gas bubbles appear, there's some tiny sample of the gas bubbles with pink circles, and a tiny sample of the liquid, it looks like has a mixture of the green circles, which would be the solid bath bomb, some blue circles, which would be the water, and some question marks, so maybe there's something more in there. Maybe yours looks like that, maybe it does not. This is what this class consensus model looks like. Be sure that you check out your class consensus model when you return to class. Sometimes as we're learning about new things, it can be helpful to think about related phenomena. So things that are related to bath bombs, maybe things that remind you of what you saw happening with the bath bombs. So on a new page in your notebook, I would like for you to title it Related Phenomena, and then add as many things as you can that remind you of what you saw with the bath bombs. Be thinking about phenomena that might happen due to the same sort of things that caused the bath bomb to do what it did in the water. Go ahead and pause here as long as you need. Click play when you're ready, and I'll show you the list of related phenomena that my students came up with. So my students thought that it reminded them of Coke and Mentos, the elephant toothpaste experiment, if you've seen that. They thought the sugar cube it reminded them of a sugar cube in liquid, I assume because of the dissolving, but I'm not sure. It might have been just the cube shape. Opening a Sprite or any other carbonated drink, Pop Rocks candy, hot cocoa bombs, and dry ice and water. Maybe you have some of those, maybe those are new to you. So now that we have looked at some related phenomena, we've tried to make sense of our understanding, I'm going to ask that you write down some questions that could help us figure out what's going on. So your questions can have anything to do with the phenomena we've explored so far or the related phenomena that we just brainstormed. So you can go back to your Notice and Wonder chart that we made earlier, your initial model and or the class consensus model, and that list of related phenomena. If you were in the classroom, you would write these on a sticky note. If you have a sticky note, please write them there. And if you don't, go ahead and just make some space on the bottom of a notebook page to add some questions that you really feel like you need answered in order to figure out what's going on with this. Pause here as long as you need. You can write 1, 2, 3 questions, and I'll show you what we would do with those questions back in the classroom on the next part of the video. So click play whenever you're ready. So once you and all of your classmates had your sticky note of questions, we would create what's called a driving question board. So we would get in a scientist circle and everyone would share their question, and then if you had a related question, you could share that. Since you weren't able to participate, your class, I'm sure, has a driving question board back in the classroom, and I'm just going to share this example driving question board. So lots of sticky notes up here, lots of questions that students have, and they're kind of grouped into some different categories. So it looks like questions asking about the fizziness, questions about the scent, what would happen if you put the bath bomb in different liquids, some safety pieces, some miscellaneous or other questions, the chemicals or the ingredients in them, and the temperature. So your question, I assume, will fit into one of those categories. This is the digital version of my class's driving question board. It's a little bit easier to see, so you could see if your question was the same as any of the questions that my students asked. Now that we have all of these questions that we really feel the need we need to answer, what kinds of investigations could we do or other data that we would want to look at in order to figure out answers to these questions? So they could be investigations or data that would help us answer a question you had, a question that was on the screen previously. So you're going to title a new page Ideas for Investigation and list ways that we could try to answer the questions that you asked or the questions that my class came up with. So if you need to rewind just a little bit, you can do that as well to see some other students' questions. Pause here as long as you need. When you're ready, click play, and I will show you some other investigation ideas from a class. So here are some of the ideas for investigation that another class came up with. Yours might be on here, and it's possible these are entirely different investigation ideas. I bet your class has different investigation ideas as well. So go ahead and look through this, see if any of these look feasible, doable for you and your class, and hopefully you'll be able to do some of these investigations and start to get those questions answered when you return to your classroom. Thank you so much for joining me as we walked through this first lesson of your new science unit. I hope that you and your classmates are able to answer lots of questions that you came up with and do many of the investigations. If you have questions about what you missed, please reach out to your teacher and other students.